You can already mark a special day on your calendars. It's the day when an extremely rare starburst illuminates the night sky with bright light. We all see a nova that results in a brand new star appearing in the sky for weeks. This star shines brighter than everything else around it, and you don't even need a telescope to see this cosmic spectacle. Nova can be seen with your own eyes for weeks. Novas are unusual stellar explosions in which massive amounts of matter suddenly explode onto the surface of a white dwarf star. The explosion temporarily increases the star's brightness by a factor of 1,500, and the aftermath of that explosion appears as a new star in the night sky for days and weeks. Amateur astronomers know the Corona Borealis, or Northern Corona constellation. Those who are less familiar with the night sky will find the Corona Borealis among the better-known constellations Boötes and Hercules. If you see very bright stars that almost form an arc, you are in the right place. A new star will appear within the arc of the new date. White dwarfs are not ordinary stars. They are the remnants of stars that are similar to our Sun, but are essentially already dead. As they run out of fuel, the smaller stars collapse to form white dwarfs, which are very dense and hot. White dwarfs are only about the size of Earth, but have an impressive mass of the Sun due to their extreme density. These stars have a strong gravitational pull that allows them to suck matter from neighboring stars. A white dwarf can survive for a very long time, even if it is no longer in nuclear fusion. It cools slowly and often exists in this strange state, drawing matter from its surroundings. Dead stars accumulate so much mass that they explode at a critical threshold. The phenomenon is known from binary systems where the companion star exploded into a red giant and thus reached the end of its life. Compared to a white dwarf, a red giant is much wider and appears more spacious, but is not as dense and thus loses mass to its much smaller but heavier companion. Essentially, hydrogen is extracted, which then forms a burning mixture on the surface of the white dwarf. In the case of T. Corona Borealis, this mixture dissolves in a huge explosion every 80 years or so. The next explosion will take place in September 2024. There is a lot of excitement. The scientific community is just as enthusiastic about Corona Borealis as we are. Today, the constellation and the nova are clearly visible to the naked eye, although the spectacle is more than 3,000 light-years away. Although we are witnessing this event almost live, we are actually seeing something that happened 3,000 years ago. 3,000 years ago on Earth the Iron Age began. The Egyptian culture flourished and the first cities appeared in Greece. But for us, the nova is now a reality because its light now reaches the retinas of our eyes or the observation mirrors of our telescopes. T. Corona Borealis allows us humans to participate in this spectacle every 80 years. 3 of these innovations are now very well documented. The oldest report dates back to the 12th century and describes the miraculous appearance of a new star on the northern crown. Scientists have intensively observed the white dwarf T. Corona Borealis in recent decades and studied its behavior in detail. Since 2015 and 2016, increasingly unusual brightness fluctuations have been observed. Other signs were an increase in radio and X-ray radiation. The current observations are exactly similar to the activity seen before previous outbreaks of T. Corona Borealis species. The last novenas of 1866 and 1946 were particularly well documented, so scholars can easily compare today. In 2018 and 2023, the brightness fluctuations caused excitement in the astronomical community. The signs increasingly resembled patterns seen before the 1946 eruption. In 1866, scientists were waiting for the birth of a new star. Famous astronomer William Huggins observed the nova in the constellation Corona Borealis in his notes. About 80 years later, scientists had a better chance and detected the increase in brightness as an explosion in a distant star system. Today, we use our best telescopes to document and observe this important cosmic event as realistically as possible. In addition to the telescopes, new satellites target the 2 stars around the clock. These missions will record the exact amount of matter absorbed by the white dwarf and the temperature changes on its surface. These precise measurements allow us to make very precise predictions about when the critical mass will be reached and when the long-awaited thermonuclear explosion and nova will finally occur. The thermal core is the power of 476 trillion hydrogen bombs. The hydrogen bomb is one of the most dangerous weapons we humans have ever developed. A medium-sized hydrogen bomb can level an entire small town. When the nova is visible, Corona Borealis will explode with the incredible power of 476 trillion hydrogen bombs. Scientists call the process that leads to this huge explosion and bright nova thermonuclear escape. It begins with a white dwarf accreting large amounts of matter. This substance consists mainly of hydrogen. It accumulates as a thin layer on the surface of the white dwarf, and then forms an accretion disk around the white dwarf. The constantly flowing matter is drawn deeper and deeper by gravity to the surface of the white dwarf, where it is compressed and heated. The more material the white dwarf attracts, the more the pressure increases. Hydrogen and heat form an increasingly explosive mixture that goes out when a critical amount is reached. Density and temperature start a thermonuclear shaft, and the power of trillions of hydrogen bombs is released on the entire surface and surroundings of the star in less than a second. Suddenly, the brightness of the white dwarf increases by a factor of 1,500 or even more. The temperature of the white dwarf Corona Borealis is about 10 million degrees Celsius during the destructive explosion. Under this immense heat, hydrogen atoms begin to fuse into helium. This is essentially the same reaction that occurs in the cores of stars, but since in this case the mass is on the surface of the white dwarf, the explosion is quite different. When hydrogen fuses with helium, so much energy is immediately released around the star that the explosion throws the outer layers of accumulated matter into space. Then we get our first glimpse of nova. With satellites and telescopes pointed at the white dwarf this time, we will be able to experience the star's lightning closer and closer than ever before. The extreme increase in brightness is temporary, but the nova remains visible for days or even weeks after the actual explosion. The white dwarf is slowly returning to its normal brightness level. If you observe the nova, you can watch the bright spot of light slowly fade each night. New TCB is clearly visible. This star system should definitely be looked at now before a new one. A white dwarf cannot be seen with the naked eye. It shines too dimly for that. At the moment of new, it really seems that a new bright star appears from the moment. Scientists are already tracking each increase in brightness and documenting the changes daily. Those with good binoculars may already recognize the flicker of the Corona Borealis virus. We see the nova days or weeks after the explosion. This new star is very easy to see even for people without a telescope or binoculars. Even if you live in areas with a lot of light pollution, you can spot a suspected new star without any help. At its brightest, the nova appears brighter than many of the sky's brightest stars, apparently shining as brightly as Arcturus or Vega.
After a few days, the brightness of this white dwarf will slowly decrease until the star finally reaches its normal brightness and is barely visible to the naked eye. With the help of telescopes or binoculars, you can see the details and observe the brightness of the star for several nights. The whole event will probably take a week or two. If you want to compare, you should look at the constellation before the nova or watch the big star burn slowly. The last new one is stellar death in sets. We humans see a nova in the Corona Borealis system every 80 years. How long Corona Borealis will continue this show is uncertain. It is certain that the white dwarf is losing more and more of its power. Will the last of its light finally fade? Or will it explode as one last bright nova? A white dwarf is basically just the leftover core of a burned-out star that wasn't massive enough to go supernova. After the outer layers are stripped away, what remains is a dense star composed primarily of carbon and oxygen. These stars cannot generate their own energy through nuclear fusion and gradually cool down. However, because white dwarf matter is very dense, their immense gravity pulls the matter away from the surrounding region. As a result, new explosions can occur repeatedly over thousands or millions of years. However, when such a white dwarf reached the magical limit, the final disaster would occur. Above the so-called white dwarf at the Chandrasekhar limit of about 1.4 solar masses, it can no longer remain stable. The star collapses under its own gravity and disappears as a magnificent Type 1 supernova. This supernova is extremely bright, and for a few moments it shines brighter than all the stars in the galaxy combined. After the event, a new star can also be seen, which slowly disappears, and then a black hole, or neutron star, forms where the white dwarf once was.